The Andromeda Galaxy, a massive collection of hundreds of billions of stars, is on a collision course with our own Milky Way. This impending crash, expected to occur in about 4 billion years, will cause both galaxies to merge in a way that will dramatically alter their structures. The Andromeda Galaxy, a key player in expanding our understanding of the universe, has been the subject of study for over a century. It was Andromeda that helped demonstrate that the universe does not revolve around Earth, reshaping our perception of the cosmos. Until the early 20th century, our understanding of the universe was limited. The Milky Way was once believed to be a faint band of light across the night sky, primarily because early technology could not distinguish individual stars. It wasn't until the early 17th century that Galileo Galilei, with the help of a telescope, revealed that the Milky Way was not just a band of light but a vast collection of stars, planets, and other celestial objects. His work shattered the idea that the Milky Way was the center of the universe, revealing it to be part of a much larger, sprawling cosmos. In 1750, the English astronomer Thomas Wright proposed that the Milky Way was a flat disk of stars, including our solar system. While this theory was limited by the technology of the time, it laid the groundwork for future discoveries. By the 1920s, astronomers like Edwin Hubble, using the Hooker telescope at Mount Wilson Observatory, confirmed that distant nebulae, including Andromeda, were separate galaxies, each containing billions of stars. This groundbreaking discovery significantly changed our understanding of the universe. The Andromeda Galaxy, also known as M31, has been known since at least the 10th century, when the Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud in the sky. Al-Sufi's keen eyesight allowed him to observe Andromeda without optical instruments, which was possible because Andromeda is one of the few galaxies visible to the naked eye. In 1612, Simon Marius offered the first telescopic description of the galaxy, setting the stage for future observations. In 1764, Charles Messier catalogued Andromeda as M31, helping to cement its recognition. A major leap in understanding Andromeda occurred in 1864 when English astronomer William Huggins analyzed its spectrum, distinguishing it from typical nebulae, which was crucial in confirming its status as a galaxy. Andromeda is enormous, with a mass estimated to be 1 to 2 trillion times that of the Sun and an age of around 10 billion years, indicating a rich history of development through the merging of smaller protogalaxies. Initially, astronomers thought Andromeda was much larger than the Milky Way, but recent research has revised these estimates, showing that the two galaxies are much more similar in size than previously believed. Andromeda's physical dimensions are impressive, with a diameter of about 220,000 light-years compared to the Milky Way's 100,000 to 175,000 light-years. One of its most captivating features is its active galactic nucleus, powered by a supermassive black hole weighing between 110 and 230 million times the mass of the Sun. Observations using advanced telescopes like the Hubble Space Telescope have revealed two focal points in Andromeda's center, with one slightly off-center, suggesting intense gravitational interactions and the presence of a massive black hole. Andromeda also contains around 460 globular clusters, each with thousands to millions of stars, indicating the galaxy's history of cosmic cannibalism, where smaller galaxies were absorbed, contributing to its stellar population and diversity. Recent observations suggest that Andromeda may be evolving from a typical spiral galaxy into a ring galaxy, characterized by a circular arrangement of bright, young stars. Ring galaxies can form through cosmic collisions, such as when a smaller galaxy passes through the center of a larger one, creating unique ring-like structures. The inevitable collision between the Milky Way and Andromeda, set to begin in 4 billion years and continue for the next 2 billion, will be one of the most significant events in the history of both galaxies. This cosmic merger will eventually lead to the formation of a new, larger galaxy, informally referred to as Mila by astronomers and fans. The merging process will involve immense gravitational interactions and tidal forces that will profoundly affect both galaxies. As the Milky Way and Andromeda approach each other, their gravitational forces will distort their shapes. Stars, gas, and dust from each galaxy will be drawn toward each other, creating elongated tidal tails and triggering a series of complex gravitational interactions. The merger will not be a smooth process, Instead, it will involve dynamic changes as the galaxy's structures are gradually reshaped. One of the most dramatic outcomes will be the formation of new star clusters. As the gas clouds within the galaxies collide and compress, they will trigger intense star formation, creating stellar nurseries where new stars are born. These newly formed stars will often group together into clusters, contributing to the stellar population of the new merged galaxy. At the same time, the gravitational upheaval will alter the orbits of existing stars. Some stars previously in stable orbits around the centers of the Milky Way or Andromeda will be flung into new, more elliptical paths, and some may even be ejected from the combined galaxy entirely, becoming rogue stars wandering in intergalactic space. The redistribution of stellar material will also lead to the creation of new, complex structures within the merged galaxy. The gas, dust, and cosmic debris from both galaxies will settle into new formations, potentially creating massive regions of star formation, twisting arms, and entirely new galactic features that blend the unique characteristics of both the Milky Way and Andromeda. The supermassive black holes at the centers of both galaxies will play a crucial role in the merger. As the two galaxies coalesce, their central black holes will eventually merge to form an even larger black hole at the heart of the new galaxy, Mila. This supermassive black hole will become an immense source of energy, profoundly influencing the evolution of the newly formed galaxy. The collision of the Milky Way and Andromeda will be a transformative event, reshaping both galaxies and leading to the creation of a new cosmic entity that will stand as a testament to the dynamic and ever-evolving nature of the universe. As gravitational waves and radiation ripple through space, the final stages of the merger between galaxies will be catastrophic, releasing enormous amounts of energy. This collision will create a single, much larger supermassive black hole at the center of the newly formed galaxy, surrounded by a swirling accretion disk of gas and dust. The formation of such a powerful central engine will have profound implications for the evolution of the supergalaxy, influencing star formation and affecting the dynamics of gas and dust within the galactic core. This may even trigger quasar-like phenomena as matter falls into the black hole, emitting intense radiation across the electromagnetic spectrum. On a larger scale, the merger of the Milky Way and Andromeda galaxies will contribute to the ongoing evolution of cosmic structures. Galaxy mergers and interactions are essential processes in the hierarchical model of galaxy formation, where smaller structures merge to form larger and more complex systems over immense periods of time. Studying cosmic events like the one between the Milky Way and Andromeda helps astronomers understand the forces driving galaxy formation and evolution. By observing how stars, gas, and black holes interact during such events, researchers can test theoretical models of galaxy mergers and refine our understanding of the processes involved. The merger will also have significant consequences for the distribution of dark matter in the newly formed supergalaxy. Dark matter, an invisible and elusive form of matter that makes up much of the universe's mass, plays a crucial role in shaping the structure of galaxies and their gravitational interactions. During the merger, the gravitational forces exerted by the dark matter halos surrounding the Milky Way and Andromeda will merge and affect the overall distribution of dark matter in the new galaxy. Observing these effects will provide valuable insights into the nature and properties of dark matter, helping astronomers unlock one of the biggest mysteries of modern cosmology. Furthermore, the merger between the Milky Way and Andromeda offers a unique opportunity to study the formation of galaxy clusters and superclusters. These massive structures, composed of multiple galaxies bound together by gravity, are the largest known objects in the universe and provide key insights into the large-scale distribution of matter and the formation of cosmic web-like structures. As the Milky Way and Andromeda merge, they will bring their respective satellite galaxies into the process. These smaller galaxies, orbiting around their larger hosts, will either merge with the new supergalaxy or be destroyed and absorbed into its vast stellar and gas halo. The fate of these satellite galaxies will depend on their orbits and velocities relative to the merging system, with some potentially surviving as dwarf galaxies within the new supergalaxy, while others may be disrupted and assimilated. While the collision itself won't directly threaten Earth, the gravitational disturbances and influx of cosmic radiation from the merging galaxies could subtly affect our planet's environment and exposure to high-energy cosmic rays over geological timescales. Additionally, the formation of the new supergalaxy will dramatically alter the night sky, with a merger changing the positions and distributions of stars, star clusters, and nebulae. This could lead to the creation of new star systems and celestial landmarks, which would shape the cultural and navigational aspects of any future civilizations that might arise in the distant future. Ultimately, the impact of the Milky Way-Andromeda merger represents an extraordinary cosmic event on an immense scale. It will transform both galaxies, creating a new supergalaxy that blends the materials and characteristics of its progenitors into a unified celestial entity. From the reshaping of spiral arms and the formation of new star clusters to the coalescence of supermassive black holes and the redistribution of dark matter, every aspect of this merger will leave a lasting imprint on the future evolution of our local group of galaxies. Studying this event offers astronomers a rare opportunity to witness the immense power of gravitational interactions in shaping the universe we inhabit. It serves as a reminder of the dynamic and ever-changing nature of cosmic evolution, where galaxies collide, merge, and ultimately give birth to new structures and phenomena that continue to inspire awe and curiosity in our exploration of the cosmos. The merging of the Milky Way and Andromeda galaxies will create a monumental shift in the cosmic landscape, forming a new supergalaxy known as Mila. This grand transformation will result from the collision and fusion of these two galaxies, combining their material into a vast, intricate structure composed of new star clusters, rearranged galactic orbits, and reformed cosmic features. This process of immense development, driven by the collision, will reshape the future of the nearby galaxy group, offering a fascinating glimpse into the long-term dynamics of cosmic interactions. The merger will dramatically alter our night sky and potentially affect Earth's environment, habitats, biodiversity, and climate. However, this event will occur long after humanity is gone, as our sun will have already evolved into a red giant, making our solar system inhospitable in about 5 billion years. The merging of Andromeda and the Milky Way raises questions about the fate of our solar system and the formation of new cosmic structures. These galactic interactions will create a fresh cosmic environment, possibly with habitable zones for life forms, though vastly different from what we know today. The resulting Mila galaxy will be a testament to the universe's ever-changing nature. The collision, expected in approximately 4 billion years, will be an awe-inspiring event, marking the culmination of a gravitational dance that began billions of years ago when these two massive galaxies first began their inevitable journey toward each other through the vastness of space. As the merger progresses, one of the most notable changes will be the transformation of the galaxy's spiral structures. Currently, both the Milky Way and Andromeda are spiral galaxies, characterized by their arms extending outward from a central bulge, shaped by the rotation of stars and gas around a central core. As the galaxies approach each other, gravitational forces will warp these spiral patterns, stretching and pulling their arms into elongated tidal structures, composed of stars, gas, and dust torn from their original galactic orbits. This dynamic process will result in a chaotic yet mesmerizing display across the newly forming supergalaxy. The collision will trigger intense bursts of star formation, as gas clouds from both galaxies compress and heat up, giving birth to massive new star clusters. These clusters will serve as nurseries for young stars, whose energetic radiation will illuminate the surrounding cosmic dust and gas, creating new stellar populations. The merger will not only impact the appearance of planets but also their internal dynamics. The gravitational interactions between stars and gas clouds will lead to a reorganization of their orbits and speeds. Some stars will be ejected into more erratic orbits, while others may be flung out of the merging system entirely, becoming rogue stars drifting through intergalactic space. Meanwhile, the supermassive black holes at the centers of the Milky Way and Andromeda will play a crucial role in shaping the future of the combined galaxy. These enormous black holes, each millions of times more massive than our Sun, will eventually move toward each other, influenced by gravitational forces, and likely merge as well, further altering the structure and fate of the Mila galaxy.